If you're looking for the last episode related to Kubecon London, then this episode is for you. Welcome back to the Is It Observable YouTube channel. Today's episode is going to be special. It's going to be related to Kubecon London 2025. As you pay attention, I released already 2 episodes. So episode 1, more on the Cloudy projects and Observatory Day and the first day. The second one, more about Steadybit, the profiles and so on. And this episode here is, of course, I promised it's the last episode about Kubecon London. We're going to share about a few things. First, Weaver. So during Observatory Day, there was a talk about Weaver. So OpenTelemetry has a project called Weaver. So I'm very interested to hear more about it, what it does, and how we can utilize it in our environments. Then I met a very interesting chaos engineering solution called Steadybit. So I was eager to learn about this solution, what we can achieve, how you design the experience. So Steadybit will deliver a demo for us to share more things about their solutions. And last, if you pay attention, Polar Signals that are delivering a continuous profiling platform has released a few months ago an open source project to monitor your network. So I was really eager to get some news. So I asked Frederic to get an interview. So Frederic will share some news about the project, what it is, how we can use it, what type of metrics or logs we're going to get from these solutions. So if you enjoyed today's content, don't forget to like and subscribe to the channel. So follow me in London. And now the Kubecon, let's go for London. Last day at Kubecon, time to pick up the shirt, do one more interview, and go back home.
Josh Suereth. I'm one of the OpenTelemetry Technical Committee members, and I've recently been working a lot with semantic conventions in Weaver, which we just gave a talk about at Kubecon.
My name is Laurent Quérel. I'm working for F5 Networks, and I'm a maintainer for 2 open telemetry projects. The first one is Hotel Arrow. It's an optimized protocol for the transport, and we are entering into a second phase to optimize the data processing. The second project is OpenTelemetry Weaver.
We had a talk yesterday called Observability by Design. The theme of this is how to start treating observability as a first-class citizen in your entire, software development lifecycle. So the idea is, we've all made changes to like metrics, logs, spans, and then our dashboards break, and we don't want that to happen. We want to start actually having testability, confirmability with like how things work. So in OpenTelemetry, we've actually designed a system for semantic conventions to make sure that, from release to release to release, we're not breaking dashboards, we're not breaking the ecosystem. We want to make sure all of this works. That tool is actually available for you to use for your own projects. And we wanted to show how that tool works, how to use it, how to integrate it, and what the different pieces and capabilities are with a demo. So the talk was called Observability by Design. The tool is called OpenTelemetry Weaver, which you can find on GitHub.
I started Weaver, I think it was 1.5 years ago, even before to make it an OpenTelemetry project. The goal was to help the team inside the F5 to specify their telemetry, everything that was instrumented in the various projects, from Nginx to Big AP and few other F5 projects or products. The idea was to have a common format to specify every instrument, every metric, every span, every logs, events, in order to create some internal documentation, and then this documentation could be shared with customers. So the idea was initially to simplify how to exploit the various information that we are generating in terms of telemetry for the product.
So the way Weaver works is you start by defining what the signals you want to generate are. So you start by defining, like, here's the metric name I want, here's the set of units it has, here's the attributes or labels I want on that metric. You would do the same with events, you do the same with spans. Like, here's the span name I would like, here's the metrics, here's the attributes on that span name. From there, Weaver has a set of things it can do. So if you check in that definition, we can actually do comparison checks version to version to make sure the attributes that you said are required by dashboards are not removed. We can also generate code for you. So we can actually generate code that will make sure when I produce a metric, when I produce a span, when I produce an event, that it matches the exact shape I said it would be. And finally, it has the ability to generate documentation.
So another set of capabilities that will be integrated into this live check Weaver command is to validate the quality of the data itself. So it's not only at the name level of attributes metrics. Obviously, we can check that we are following some naming convention, but we also want to check the data itself. Is it consistent with some kind of telemetry catalog, semantic convention that you are using? So that will capture issues like a developer that didn't use the proper type for a specific attribute. You expect, for example, an integer and unfortunately it was a float or it was a string. We could capture this kind of issue. Some other aspect like making sure that your instrumentation for traces propagate properly the trace context or the baggage headers. That's the kind of control we could add directly in Weaver inside the CI/CD pipeline for all your integration tests. So you are sure that the propagation, the trace propagation information is there, and it's an important source of issues, in fact, in production. So having this kind of control in place will be a real nice addition, and we are working on it.
There's a few other features that are coming into Weaver. So there's currently a prototype where you can use it to take the definition and actually send OpenTelemetry protocol to your backend with examples that match the specification you said. So if I define a metric, say our example was like an eBay auction app, like a server that handles auctions on eBay, right? If I wanted to find a metric that counts auctions and has a set of labels, this would actually fire a pretend metric to my backend. I could use that to design and define my dashboard. And then when I do the code gen and put this into my ecosystem and the data actually starts flowing, I have a dashboard already that it generated from what I think the data will be and should be. Additionally, we're adding features into Weaver where you can set up integration tests. Well, you will run this as an endpoint that accepts data via OpenTelemetry protocol. And if you send it data that doesn't match the definition that you had, it would fail. So you can put it in your CI/CD pipeline and have a test feature that says, okay, cool, this project now generates the data that I intended. So it's trying to complete that end-to-end lifecycle. How do we make this work with the ecosystem, like with the actual, dashboards and databases and that sort of thing? So OpenTelemetry, as most know, doesn't actually provide a database or dashboard ecosystem, but there are great databases and dashboard ecosystems in Kubernetes. We're actually talking with Prometheus. There's a talk later by Bartek and Ariana, and that actually is showcasing a feature in Prometheus where you can specify a version of a metric. And if you have multiple instances of a metric being produced from different versions, but we know how to convert between them, it will automatically do that at query time. So you can define a dashboard that says, I use this version of a specification. And then let's say a metric name changes. But I have because Weaver can do this, it actually does differences between definitions. I have that difference file and I've sent that to Prometheus. I can have the new metric get reported, the old metric get reported, but my dashboard doesn't break because at query time, Prometheus is doing the translation. So that's a feature we're actually working on with database teams, with other observability vendors as well, to try to make this be a thing that everyone can rely on and use. So right now we're still in the nascent phase of like, let's make sure people can define it, get good docs, and make sure that they generate this. That downstream thing, that's the future. That's like the next few years, yeah.
So we have vendors that start to basically to use Weaver because it's a very extensible tool. It was part of the design principle of this tool, making sure that we will be able to integrate Weaver with other observability backend, with enterprise data catalog, with databases also, dashboard system. So Weaver is designed where in a way that where we have some template engine, and you can basically generate artifact that could be a dashboard description, like a Grafana dashboard description. It could be also a SQL or a DDL file representing all the tables where you could store your own telemetry objects represented with this semantic convention registry, and so on. You can imagine many ways to integrate Weaver and semantic convention and open telemetry with not only the observability ecosystem, but also the data ecosystem in general. That could be also used for AI, ML kind of integration, because when you are using AI, ML, you not only need to rely on data, but also on the metadata representing those information. So leveraging that will be super useful. There are some query engine using generative AI to help people express their query, their request in natural language, combining the semantic convention, the description that you have for each object. It's super useful for a such approach to optimize the result. That's another example of how that could be used.
Weaver is built to be an engine, and so actually it's fully customizable. So we're using, if you're familiar with the open policy agent in Kubernetes, there is a rule-based engine for allowing like network things to come in. We actually use that same rule system for allowing observability definitions. So we pass the observability definitions into the rule engine, and if it passes, it passes. If it doesn't, it doesn't. So you can fully customize what you want. Similarly, for doing code generation, we're actually using the Jinja templating system. It's like a Python ecosystem thing. So we pass your definitions into Jinja. If you want to fully customize code generation, it's there. You can do whatever you need. If you want to filter things, you know, the core of Weaver is a very flexible engine. What we're working on is, I think the getting started experience is still a little hard because that core is fully exposed. So we're working on actually adding defaults and out of the box so that you don't have to do it all yourself. Today, you kind of have to like build all the components or copy them from OpenTelemetry, which is what we've done in our demo.
So for people that want to contribute, the best way to communicate with us is with Slack. So we have this hotel-weaver Slack channel that you can, where you can talk with us. Another way is to talk through GitHub with GitHub issues and just also contribute a PR. And we welcome everyone to join the party and help us on that.
Frederic. I'm the founder of a company called Polar Signals, and I've been kind of in the cloud native ecosystem for almost 10 years now. I'm a maintainer of the Prometheus project. I'm a maintainer of the Tanos project. I'm the co-creator of the Prometheus operator, which maybe some folks are familiar with. Some of the very recent things that we've done that I think are really exciting. Actually, just on Tuesday, we released GPU profiling, which obviously for AI workloads, but anything that uses a lot of GPU can get a lot of value out of. Another thing that I think is really interesting is we've already had kind of distributed tracing correlation for Go for a long time. And we're now bringing that to Rust, to C, C++, but also asynchronous executors like Tokyo and Rust. So that's super exciting. So we're expanding the space of what's possible there. Let me start why we even looked into building something here. So basically, we found ourselves sometime last year that we realized that on our cloud bill, a very major portion of our cost was cross-zone traffic. If people aren't familiar, 1 gigabyte of cross-zone traffic on GCP, on AWS, and on Azure costs 1 cent. And so, for a terabyte of data that you transfer, you're paying a lot of money for. And so in the Polar Signals Cloud product, we transfer a lot of data every single day, many, many, many terabytes. And so that's gotten kind of expensive for us when it really didn't need to. Nothing about our product has to communicate traffic across zones. It was just something that happened to have happened kind of naturally. And this happens a lot throughout the industry. And it turns out that cloud providers and existing kind of monitoring infrastructure was not particularly good at telling us exactly which workloads were causing this cross-zone traffic. And so we ended up creating this project called KubeZonnet, KubeZone networking. Very imaginative naming here, but it kind of did the job. And it's an eBPF-based project that essentially correlates source and destination IP packets and figures out whether this packet has traversed the zone boundary. And when it does, then we attribute that to a container, a pod in Kubernetes, and that ultimately allows us to understand which workloads are ultimately causing all this traffic. There are two major things that this project exposes. One are metrics, and the metrics are aggregated by the outgoing, the process that causes the network traffic to leave that node. That's aggregated by the pod. But then we also have very detailed flow logs that tell us not just the outgoing pod, but also from which pod to which pod the traffic is going. Because sometimes it's interesting to also know which client is the thing that is causing the problem. And so those are the two major pieces of information that this project exposes. Project is actually made up of two components. One is an agent that, yes, exactly, is deployed through a daemon set. And that's the component that essentially captures all the IP packets and over a 10-second period aggregates all the amount of bytes that were sent between two IPs. And then there's a server component that then actually figures out, did this this communication cross the zone boundary? Because that's ultimately the part that we're really interested in. Total network statistics we were already getting out of other kinds of tools, so we were only really interested in understanding this very detail of when does cross-zone traffic happen. So that's really what this project focuses on. So today it's all just a /metrics endpoint that you can scrape with any Prometheus compatible system. And then the logs are just regular logs, log2 standard out.
My name is Nils Wloka. I work as the Chief Product and Technology Officer for Steadybit, which is a startup in the chaos engineering space. Yeah, so in case you might be wondering what we are doing differently in terms of chaos engineering, I think what sets us apart is that we wholesomely embrace the method as such. So we want to make it as accessible and safe as possible to do chaos engineering at any scale, starting from a single team and extending into the wider organization.
In order to do that, we concentrated on user experience, on the whole thing being safe and ideally abstracting away all of the technical complexities. Plus, on the other hand side, because this only becomes relevant once you've reached a certain complexity, we also wanted to grow along your environments, so it's inherently extensible and can integrate with pretty much every enterprise level environment. Yeah, this also means that Steadybit obviously needs to be available both as a service, a software as a service, and as a on-prem solution. As with every chaos engineering solution, there will always be some part that needs to go into your environment. In our case, this is heavily modularized so that we can aim for least privilege principles when deploying extensions that talk to certain parts of your infrastructure. So we can be conservative when it comes to resource consumption as well. So you get to pick and choose what you need in order to validate your architecture hypothesis and to run the experiments you are aiming for, and then you basically install the extensions that match your ecosystem. For example, Kubernetes or any cloud provider or any observability solutions like Dynatrace. Let me just introduce you to how the product looks in action. So this is assuming that you have installed our components into your system under test. And the heart of every chaos engineering solution is how you can design experiments. With Steadybit, what we are looking at right now is the experiment editor. It is a time-based canvas, so you can basically compose your experiment out of all the different building blocks, and I've pre-selected the ones that are available for Kubernetes environments. So you see 38 actions, 29 pre-made templates, and the idea here is that you really start working from a hypothesis, right? Instead of just doing the fault injection stuff, you describe what you want to test for. It might be an architecture requirement, might be a preconception that you have about your system under runtime conditions, and then you drag and drop these building blocks onto the canvas and configure them so that they represent the thing that you want to check for. Since we are at Kubecon, it makes sense to dive a bit deeper in what capabilities we have related to Kubernetes. So on the building block side of things, Kubernetes consists of multiple logical and physical layers, right? And we can do all types of resource-based, network-based, and state-based attacks on all levels of the infrastructure, right? From the underlying compute, so that would be host attacks that work on an OS level, to the container engine, to the orchestration engine. So there's everything from network-based attacks like inject latency, blocking traffic, right, to draining a node or simulating a rolling deployment. And I think one of the things that we do somewhat differently to other chaos engineering solutions is that we distinguish between the fault injection and the check, right? So there are building blocks, and you can see this as blocks of different colors. So dark blue is something that we do to the environment. In this particular case, it's a container delay traffic attack. And light blue is what we call checks. And checks are there in order to check the precondition or the post-condition for any given experiments. So in this particular case, I'm asserting that my demo environment is in a stable condition by checking whether all the required deployments have all the desired pod counts, and I'm checking a post condition by doing a built-in synthetic check, but I could also connect to almost every observability solution on the planet, Dynatrace, Grafana, directly reading PromQL queries and interpreting their results. And the way this works is I can configure this to either short circuit the experiment, to not even start if the system is in a stable state, or I can use this to check a precondition to make the experiment fail or succeed. And I think one of the things, especially when talking about observability and chaos engineering, that's interesting to keep in mind, that I can also configure the checks to fail the experiment if a specific alert isn't raised, right? So I could use this to effectively test drive my observability strategy. And I mean, we've so far discussed fault injection or chaos engineering. We've discussed observability integration. I believe that the third side of the triangle is end-to-end testing, including performance testing. This is why we not only integrate with observability solutions and your hardware under our software and infrastructure under test, but we also integrate with load testing solutions like Gatling, JMeter, K6. So I can reuse my existing load tests by just pulling in a building block onto my canvas and then connecting it to whatever load test I have already configured. If you want to invert control, because for example, you already have a very large test suite or any specific test framework that we can't support, everything that you are seeing in the UI is also available via API. So you could, instead of using Steadybit to drive your load test, use your load testing, integrate your load test to drive Steadybit via its API. And this is an approach that, for example, OpenText is using with their load runner Steadybit integration. I mean, usually Steadybit or chaos engineering starts in a small space, but then needs to extend into the wider organization. And we've built the tool to grow alongside you. So we have talked about typical chaos engineering by building experiments, but we also offer a comprehensive catalog of pre-made templates related to Kubernetes, specific Kubernetes good practices. We also allow you to create your own templates to facilitate rolling out from an expert group into development teams. And last but not least, if you are among the folks joining KubeCon because Kubernetes is a new thing for you and you want to learn how to effectively use it in your runtime environment, then we have also something built in that is called Kubernetes Reliability Advice, which basically checks your runtime environment against a set of community good practice and then can give you education content about fixing any obvious misconfiguration or suggest experiments to you that you should conduct in order to validate whether your configuration is effective in practice. And if you want to try all of this out, you can just head to steadybit.com. There's a free trial that you can book for 2 weeks, and it gives you basically all of the features available in the platform. And I'm happy to answer your question if you reach out to us.
That's it for today's episode, the part 3 on KubeCon London 2025. In this episode, I was very excited to learn about Weaver. I see a lot of potentials, first to control any breaking changes in our in the definition of our metrics or traces. Maybe we can also detect expensive traces or traces that are built that is not respecting our semantic conventions. So I think this is really interesting. And I think the missing piece of testing our traces, Weaver can clearly help us on that directions. Steadybit, very interesting chaos engineering solution. I like the way you design it, the way you plan your experiments. And also I like the fact that they have lots of integrations with load testing, with the various solutions. So it makes a lot of sense if you're planning to do some chaos engineering. And last, KubeZonnet, very exciting about these solutions. I'm questioning myself, what is the difference with other solutions? So I may look at it more deeply to answer those questions that I may have, or maybe you also have those questions as well. So if you enjoyed today's content, don't forget to like and subscribe to the channel. So see you soon for another episode.